In this video, we'll show you how you can predict user churn for your gaming apps using Google Analytics 4 and BigQuery ML. My name is Po-Long Lin, and I'm a developer advocate for Google Cloud.
I'm Minhas Kazi, and I'm a developer advocate for Google Analytics. If you're a mobile game developer, a potential challenge for you could be user retention. With so many games and apps to choose from, keeping users interested in your product and enabling them to come back can be really difficult. According to a study in 2019, most mobile games see only a 25% retention for users after 24 hours. That means on average, 3 out of 4 users will churn. They'll first use your app, and then after a day, they'll stop playing. So the question is, if I'm a mobile game developer, how do I reduce churn? Po-Long, you have experience with machine learning. Can that help here?
Absolutely. At a high level, you can use machine learning to predict which of your users are going to churn based on how they're behaving in the app and their demographic information. Once you have the predictions of who's likely to churn, you can then target those users who are perhaps on the fence to incentivize them to come back to the app or game, or make the game just a bit more rewarding for them to play. Predicting each user's propensity to churn, that's where machine learning can help us.
Users' propensity to churn. That sounds interesting. Maybe we can apply this to a real-life example. We have this mobile game called Flooded that's available both on the App Store and Google Play Store. Can we identify users' propensity to churn for that app?
Certainly. As long as you have the behavioral data, you can build machine learning models to predict user propensity to perform any specific behavior like churn or making in-app purchases or sharing the game with a friend, just as examples.
Okay, so here's the scenario. We have this Flooded app, and we can use usage data from there. My goal is to identify specific users who are likely to churn and then try to retain them. I can, for example, through Firebase send notifications to these users or customize the game to be extra rewarding to them. Through Google Analytics, I can segment the users and analyze different likelihoods of churn and do marketing campaigns. Or through other marketing tools, tie it together with email or other marketing campaigns. So Po-Long, how would I use machine learning to do this?
Hold on. There are a couple of steps in order to get to these activation scenarios. Let's walk through all the required steps in reverse order. So you had just talked about the last step, which is using the predictions for activation. In order for that to happen, you'll need a churn prediction model to give you these predictions on each user's likelihood or probability to churn. And you can build this machine learning model using BigQuery ML. But to create this model, you'll need to first have prepared the data in the right format for the machine learning model. So we call this step data preprocessing, which is done in BigQuery. So that brings us to the first step, which is making sure you have your data ready in BigQuery.
Great. That fits in nicely since we can use Google Analytics 4 to measure usage data for the Flooded app. We can just export that usage data into BigQuery.
Minhas, could you tell us a little bit about Google Analytics 4?
If you're not already familiar, Google Analytics 4 or GA4 is the newest edition of Google Analytics. It allows you to measure user engagement not just for websites, but also for apps. GA4 uses an event-based model, usually when the user or the app does something that's an event. If you're an app developer who's already been using Google Analytics for Firebase, you can be rest assured that it's the same data model as GA4. What's new with Google Analytics 4 is that any user, free or paid, can now export their GA4 event data into BigQuery.
And exporting data to BigQuery is really interesting, because with BigQuery, which is the data warehouse on Google Cloud, you can analyze terabytes of data in seconds. And you can also train and deploy machine learning models, as you'll learn in this video. So if you're a marketing analyst, you can train and deploy machine learning models just by writing SQL without any additional programming languages. So Minhas, how would a Google Analytics user export their data to BigQuery?
I can log on to the Google Analytics 4 property and go to the admin section. Then click on BigQuery linking. On the right-hand side, we will see that for this property, no link has been created to BigQuery. So you can click on link. Then it will ask for which BigQuery or Google Cloud Platform project to link it to. If you haven't used BigQuery before, at this point, you'll just need to set up an account on Google Cloud Platform and select the appropriate project. We'll select our project and then click Next. For our analysis, we'll use the daily export. After you've reviewed and submitted your export options, GA4 will start exporting the event data for this property to the selected BigQuery project. After a day or two, you should start seeing the daily event data in the events table. In the BigQuery UI, we can click on the Preview tab and it will show us what the event export data looks like. Each row is a unique event that occurred at a specific timestamp. You also get the event name and additional information about the event in event parameters. For example, in the first row, it looks like the event was a level complete quick play by the user. So now that we have our GA data in BigQuery, Polhong, what's our next step?
Well, in order for the machine learning algorithm to train the model properly, we need to pre-process the raw GA4 data to be in the right format. This is an example of what an ideal format might look like for the training data. Specifically, every row needs to be represented by a single user, along with a label of churned 1 or 0. We also want to include features that can help the model learn, specifically the user's demographic information, and any sort of behavioral data, such as the number of times they open the app within a certain time period. So the way this works in this data preprocessing stage is first, we'll need to identify users and the churned label, process demographic features, and process behavioral features. Then we'll combine them together as the training data. With the training data ready, we can then move on to building the churn prediction model. So the first step is making sure we have a solid definition of churn. Now your definition of churn may vary here. You may want to predict churn after 1 day, 1 week, or simply whether or not they will churn after the first 30 minutes of installing the app. That definition is entirely up to you to decide what makes sense for your app. For us, we chose to define churn as the following. After 24 hours of a user's first engagement with the app, the users who never came back we call churned. Those who come back after 24 hours, we can say they returned. That means given all the user data that we have, we want to say, based on the user information within the first 24 hours of them using the app, can we predict if they will churn or return?
But hold on. What about those users who use the app and then within just a few minutes they decide that it's not the app for them at all? Perhaps those users aren't worth targeting with any sort of incentives because this wasn't something they were looking for. I would prefer to exclude them.
That's a good point. Let's ignore users who left the app within the first 10 minutes. We'll call these bounced users. So when we build the machine learning model, we'll only look at users who didn't bounce.
So prediction model will be based only on the users who spend at least 10 minutes on the app. To prepare the user data in BigQuery, first we'll create a bounced label column. Engagement is an event when the user interacts with the app. If the user's last engagement was within 10 minutes of their first engagement, we'll consider that the users have bounced. Bounced users will get labeled with a 1 in the bounced column. Otherwise, the value is 0 for all unbounced users. Next, we'll create a label column for churned. So if the user's last engagement was within 24 hours of their first engagement, we will consider the user to have churned. Otherwise, we know that they did something with the app after the first 24 hours, meaning that they did not churn. So we give those users a value of churn equals 0. So this is what it looks like now. One label for churn and one label for bounced.
Perfect. So in the next section, we want to process the demographic information available for each user. Minhas, can you explain what demographic data is available in the GA4 data?
In GA events export, some demographic data about the user is reported automatically, like the device language and operating system, user's browser, and geographic information. You can also use user parameters in GA4 to capture additional user demographic data. For simplicity, we only chose country, operating system, and the user's device language.
And here, if there are multiple rows per user, like if they were in different countries, then you can just use perhaps the most recent demographic information to have only one row per user. Okay, So the next step is preparing the behavioral data. And this step is really important because you want to help the machine learning model learn how the user's behavior in those first 24 hours predict whether or not they churn. Minhas, what sort of behavioral data does GA4 capture, and what fields will you consider using?
As we mentioned before, each row in GA4 data is an event. Some events are automatically captured by GA4. There are recommended events for specific use cases like gaming. You can also create custom events depending on your app. Let's see what type of events we have in the flooded dataset. We'll query all the event names and sort by their count across the dataset. As you can see, there are automatically collected events like screen view and user engagement. The other events are recommended events for gaming like level start quick play and post score. From the list, we chose this subset of events to be most important for our analysis. But you can choose whichever events you think might help the ML model determine who is likely to churn for your app.
So we like this sort of result, where each row is a unique user ID, and for each user, we have some behavioral stats, like how many times they engaged with the app, how many times they started a level with quick play or ended a level with quick play, and so on.
We can achieve this by counting different events in different columns for each user.
Now that we've prepared our label, the demographic data, and behavioral data, we can combine them into a single table which becomes our training data.
A quick side note before moving on to machine learning. Let's assume that you have other demographic or behavioral data from outside of GA that you want to use. For example, the data could be in your CRM. You can import that data into BigQuery and then join them using the user ID and use that for training as well.
So with the training data ready, now we can finally talk about building the machine learning model to predict churn using BigQuery ML. In this section, we'll be using BigQuery ML to train the churn prediction model, evaluate the model, and make predictions on new users to get their probability of churning. If you're not familiar with what BigQuery ML is, it's the ML or machine learning functionality that's built into BigQuery by default. So if your data is stored in BigQuery, without needing to move it out, you can use BigQuery ML to train and deploy machine learning models directly using SQL. You don't need to know Python, R, or TensorFlow. You also don't need to set up any extra infrastructure because it uses BigQuery's autoscaling infrastructure to train and deploy your ML models. So that means you get your data storage, data analytics, and machine learning all built into BigQuery. There are lots of different machine learning model types available with BigQuery ML. For propensity modeling, you'll want to use one of the supported classification models. To keep things simple, we'll stick with logistic regression in this video as it's typically the fastest to train. You can always try to improve your models afterwards, but this gets you to a working model quickly. So to train a logistic regression model using SQL, first you'll need your training data. Select star from the table you just put together. Next, you'll want to create or replace model, followed by the project and dataset, and the name of the model, which we've chosen here to be churn log reg. Next, we'll need to specify that we want to use logistic regression, as well as setting the churned column to be the target variable we want to predict. And that's all you need. And once the model is trained, you can evaluate it in BigQuery ML. And to do so, you can use the BigQuery UI, which shows you the evaluation metrics when you select the model you've trained. You can see the metrics like log loss, ROC, precision, recall, accuracy, F1 score, and some visualizations. You can also evaluate the model using select star from ml.evaluate and then the model name. If you create multiple models, you can use something like ROC or F1 score to compare your models, with better models having scores closer to 1.0. And depending on your needs, this is where you could be iterating between training the model and evaluating the model to try to improve your model performance. There are various approaches to improving models. You can try a different model type, such as boosted tree classifier, deep neural networks, or even AutoML tables, all which are supported in BigQuery ML. You can also try to select different features, or more features, or engineer new features out of existing ones. And of course, you can also try tuning some of the hyperparameters of your models. To learn more, check out the documentation.
Great. So now with the model created, how do we make predictions on who might actually churn or return?
You can use select star from ml.predict, followed by the model and the data you want to make predictions on. Note that for the test data, it should have the same columns as you had in the training data. We can see what the model predicted in the first column, but this isn't actually what we're looking for. For propensity modeling, we actually want a probability of how likely someone is to churn, some value between 0 and 1. So for this, we'll need to extract out the probability from the third column called predicted churned probs.prob for when the label is equal to 1. To do so, you can extract the probability of churn for each user using this SQL query. Now that we have the user's propensity to churn, how do you use these predictions for activation? Minhas?
To get the data into a usable state, we can either read it directly from BigQuery or export it into Google Cloud Storage or GCS as CSV files. This query will export the selected columns into a CSV file in a GCS bucket. We can use either the BigQuery data or the exported CSV file in different ways depending on how the end tool works. For example, Firebase can directly import from BigQuery, whereas external marketing tools might need to use CSV files. In GA4, you can use the data import feature to import the predicted values as a user property. Then the user property can be used to create segments and remarketing lists. If you're using Firebase for your app, you can also import the predictions back into Firebase to tailor the user experience using remote config or send notifications to the user using cloud messaging and in-app messaging. You might also use other external tools to run marketing campaigns like sending out emails to motivate users to return. Using the steps described in this video, we should be able to do the activations and finally increase the number of users retained for the flooded app and reduce the number of users churned.
Great. So to recap, we showed you how to export your GA4 data into BigQuery, how to pre-process the churn label, demographic data, and behavioral data to get the training data in the proper format in BigQuery. Then we talked about how to train, evaluate, and make predictions using BigQuery ML. And finally, we covered a few ways to use the predictions for activations. If you'd like to follow the steps, you can check out the blog post or the GitHub notebook by going to the links in the video description below. Thanks for watching.